Okay, in this video I'm just going to briefly re-explain the idea of elasticity, and then I'm going to do the 3 sample problems that I asked you to be able to do for our next class. So the first thing to reiterate here is just what elasticity is all about. And the idea is with elasticity we're thinking about kind of stretchiness, like rubber bands are very elastic, and that's what we're really trying to determine here. Is we're doing a deep dive onto the demand, and we'll do a little on supply, but primarily we're going to look at the demand curve and understand how sensitive it is to changes in things like price and other factors like income and other goods. So that's what this elasticity thing is all about. Then in class, with this quick example, we highlighted why you might actually care. And this was the idea that if you were the seller of a good and you were thinking about increasing your price, which of these demand curves would scare you. And it turned out it was this one here, because if you had, if we just look at 2 points on the curve here, if this was the price change you were going to make, or sorry, you're increasing the price, if this was the price change you were going to make, you were going to get a relatively large response in the demand. The demand was going to drop all the way down to here from that change in price, whereas this one's not nearly that sensitive. And so elasticity is this measure that's going to help us quantify these visual differences in elasticity that we see in these 2 demand curve examples. Then in class we did this visual demonstration, and the idea was that we hung one piece of paper on this side, which was going to be percent change in price, and this is the thing we were going to push and pull on, was this side. And then we were going to see what happened up here to the quantity, percent change in quantity. And then we could get different responses based on where we moved the lever. Right now, where this is positioned, we'll kind of get an equal response. If we push down on prices by 5%, you'll get a 5% change in quantity, and that was what we called unit elastic. And then we could make this very elastic by sliding the fulcrum down to here. If we put the triangle here, small changes in prices are going to create large swings in the quantity, and so we're going to call that elastic. And then if we put the fulcrum here, we'd make large changes in price driving small changes in quantity. We called that inelastic. But the general gist here is that we're trying to see, we're going to push on percent change in price and see what happens to percent change in quantity. And mathematically we're going to capture that with this simple equation here. So we're going to, E stands for elasticity. The P that's listed here indicates the specific elasticity we care about. In this case it's price elasticity, which is again change in price of the product, how it changes the quantity demanded. And then these are basically the 2 pieces on the lever, so we're just going to take a ratio of those two to see how elastic it is. So if we get a big change in quantity and a small change in price, we're going to get if the number was like 5% over 1%, that would equal 5. That's going to be a pretty elastic, because a 1% change is creating a 5% change in the quantity. And the opposite situation would be like if we had a 5% change in price driving a 1% change in quantity, that number then would be 0.2. And so what's nice about this elasticity calculation is with a single number we can instantly understand how sensitive this product is going to be to a price change at a given point. I do note here that the negative sign is dropped. The idea with price changes anyway, when you lower the price, the quantity is going to go up, and so these would typically be opposite signs, but the convention here is that the negative sign is dropped when we think about elasticity. And you'll see why in a little bit later in a few of our units or a few chapters down the road. And then one final piece to perhaps review here is that we need to, and we did a little worksheet on this in class, but we need to understand the mathematics of how economists like us to think about this percent change quantity. It's not going to be quite maybe the way you thought about it when you learned it in math. So let's just review this percentage change idea. Say here that there's more than meets the eye. So what's the percent difference between two numbers, 80 and 100? And this is purposely worded a little bit strangely, and I'll talk about why in a second. So the first way to think about it is this calculation here, where we take 100 minus 80 divided by 80. So this is the context where we're thinking about we're starting at 80, going to 100, and asking ourselves what's the percent increase when we do that. And so the way to think about that is I've got 20 extra. When I moved from 80 to 100, I started at 80, so I divide by 80 and I get 25. A second way of conceiving of this idea is, well, what if I would have started at 100? And the idea here is that if I went from 100 down to 80, still I'm changing by $20, but if I started at 100, I would divide by this number instead of 80, and I'd get a smaller percent difference, which would be 20. And I think I mentioned in class that economists don't like this idea that you get a different number based on where you started. We want to think about percentage change being the same number whether we start at 80 or start at 100. And then the way economists deal with that is with this thing called the midpoint method, which is shown over here on the right. So we still think about the $20 or the 20 change in the numerator, but what we do here instead is, switch to color here, is we're just going to essentially average these two choices for the bottom. So instead of picking 80 or 100, we're just going to take the average of them and do 80 plus 100 divided by 2, which would be 90, which is, you would just know is halfway in between 80 and 100, and that's why it's called the midpoint method. Oops. And so, like I said here, economists use this thing called the midpoint method. But just the only thing you have to remember is that the only thing that's different is we just think about the starting point being the average of the two choices we could have made. The numerator is going to be the same in all cases, and you can see that the number turns out to be roughly halfway in between, but it's actually slightly different than taking the average of those two numbers. So it would not be correct to take 25 plus 20 and divide that by 2 to get 22.5. You can see that 22.5% is slightly different than 22.5, so we're not going to do that. And what we're going to go ahead and do is just average those denominator items. Okay, so now I'm just going to do the three problems that some of you got the chance to start after the quiz last week. So let's just go through them, and then I think you'll get a good sense for how this price elasticity of demand works. So we have this strawberries, the price is going down and the quantity demanded is going up, and we want to understand what the price elasticity of demand is. So let's remember that formula. It's the price elasticity of demand is going to be a ratio. Remember, we always put what we're pushing on in the denominator, so we're going to think about percent change in price in the denominator, percent change in quantity in the numerator. And then this problem doesn't actually give us the percent changes, so this is where we have to use this new midpoint method to come up with the numbers. So let's think about the price first. So the percent change in price, it's going from 150 to $1, so we're going to subtract those two, so we're getting the 50 cents change. And then because we don't want to pick a starting point, we're going to just take the average of the two starting points. So the two possible starting points are $1.50 plus $1 divided by 2, which will give us the 50 cents divided by $1.25, which we can do a reasonableness check that, yeah, it looks like $1.25 is halfway in between those two numbers. And then we will get 0.4 here, which equals 40%. So we're getting what we're going to call a 40% decrease in the price. And then for percent quantity, we're going to do a similar type of calculation. We have 200,000 minus 100,000, so that's our change. And we're going to divide this by the average. And rather than just do the calculation, I'm just going to reason through. Well, halfway between 100 and 200 is 150,000. That's going to be our midpoint method. And that's going to give us 100,000 over 150,000, which is going to be, when you reduce that fraction, it's going to be 2 over 3, or we can think of that as 66.7%. Now we have all the components we need. We just plug those in there. Percent change in quantity is going to be at 2/3. Percent change in price is going to be 2/5. And then if you go ahead and divide those two, you're going to get 2/3 times 5/2, which is going to be 5/3, which is about 1.67. So this is indicating that it's somewhat elastic of a product, because for a 1%, the way to interpret this is that a 1% change in price is going to drive a 1.67% change in quantity. So the quantity response is a little bit more sensitive. So that's what you do with this number once you've calculated it. Okay, so we'll move on to 3 here. So this is telling us that the present level of consumption, so Q looks like it's 4,000 movie tickets, and at a price of $5 per ticket. It's telling us the elasticity of demand is 1. Let's remember how to interpret that. That means 1% change in price is going to drive a 1% change in quantity. And using the midpoint method, let's calculate the percentage by which the owners of movie theaters must reduce the price in order to sell 5,000 tickets. So if we think about our formula here, it's going to equal 1 in this case because it's given as 1, but we need to think about percent change in price divided, or percent change in quantity divided by percent change in price. Looks like this problem is asking us to find that number, and so we need to calculate this in order to be able to solve this little proportion. So let's think about percent change in quantity. Well, we want to get to 5,000 tickets, so we're going to do our ending point minus our starting point of 4,000 tickets, and then using the midpoint method, we need to take the average of our starting point and ending point. So it's 5,000 plus 4,000 divided by 2, which is just 4,500, and this is going to be 1,000 divided by 4,500. Can kill those zeros there. I get 10 over 45. Which is 2/9. So if you punch that in a calculator, you'll get it's about 22.2%. So now we have that. So we now just have to solve this little proportion. Probably, since this is equals 1, hopefully it's pretty straightforward to see what's going to happen here. But we know that this is going to be 22.5%. We need to find this, and so what over 22% over what equals 1? Well, hopefully it's we know that that's just going to be 22.5%, and so that's going to be the percent change in price we're going to need. So we need to reduce the price by 22.5% because we need the quantity to go up by 22.5%, and we're given that the elasticity is 1. Okay, so here's our final problem. The price elasticity of demand for ice cream sandwiches is 1.2. So I'm going to go ahead and write that the price elasticity is 1.2. At the current price of 50 cents per ice cream sandwich, so that's the P, and the current consumption level of 100,000 ice cream sandwiches. We need to find the change in the quantity demanded when the price rises by 5 cents. So it looks like here we're going to increase the price by 5 cents, and we want to understand what the quantity drop is going to be when we do that. So we can use the elasticity to find that out. So if we just write our elasticity equation again, it's percent change in quantity divided by percent change in price. And looks like we're going to need to, we want to find this, and we can calculate the percent change in price here. And we're going to go ahead and use the midpoint method again, percent change in price. Well, it's telling us that the price is going to go up by 5%, so we just, or sorry, 5 cents. So we don't even have to calculate a before and after. We can just put that up in the numerator. And then we need to do the midpoint method. So our starting price is 50 cents. Our ending price is 55 cents. We're going to take the average of those to get our percent change in price, 0.05, and then 0.52, so 52.5 cents is the midpoint. Okay, so if you punch this in a calculator, you'll get 0.095 approximately, or 9.5%. Alright, so now we can go ahead and back to our price elasticity equation. We know that the percent change in price is going to be 9.5%, and we know that this equals 1.2. So we need to find here percent change in quantity. If we multiply the both sides, or just got to solve this little proportion here. So we're going to know the percent change in quantity is just going to be 1.2 if I multiply both sides by 9.5%. We'll get this. And then if I just simplify that out, I get to percent change in quantity is about 11.4%. So what this is saying is if we increase the price by 9.5%, the quantity will go down by 11.4%, but it wants actually the units of quantity here, so we'll just go ahead and calculate 11.4% of 100,000, which is going to be 11,400 ice cream sandwiches. So what this is saying is that if we increase the price by 5 cents, our ice cream sandwich production or demand will go down by 11,400 ice cream sandwiches from our starting point of 100,000 sandwiches. So hopefully that gives you a good idea about how elasticity calculations work.